After studying this module, you shall be able to understand the following. Number 1, the types of scales used in psychological measurement. Number 2, understand Nalini's fundamentalist view of measurement scales. Next, the differentiate between continuous and discrete scales used in psychological research. And finally, you will learn the define and differentiate among nominal, ordinal, equal interval and ratio scales of measurement used in physical sciences as well as psychological sciences. People differ in their physical and psychological attributes. Though it is easy to measure physical characteristics of people like height, weight, due to the availability of standardized scales or standard units. Measuring psychological characteristics raises a fundamental problem as no similar external standard exists. There is no perfect ability, personality or attitude measure with which a standardized response can be obtained. A measure of intelligence does not have the same mathematical status as does a meter scale in physical sciences. During recent years in psychology, there has been much talk about the different possible types of measurement scales, and there has been much soul searching about the types of scales characterized by different types of psychological measures. This module which you are studying deals with scale of measurement, which is the basic understanding component of psychological assessment. Scales enable us to transform the response of people into quantitative scores which form the basic of measuring attributes or characteristics. A simplified, conventional and most widely accepted classification of measurement scale comprises of 4 types known as nominal scales, ordinal scales, interval scales and ratio scales. Nominal scale is the most rudimentary type of measurement scale in which numbers are coded into categorical information. The next level of measurement is ordinal scale. In this type of measurement, a set of objects or people is ordered from most to the least with respect to an attribute, but there is no indication of how far apart the objects are with respect to the attribute. An interval scale is one in which the numbers are rank ordered and it is known how apart the objects are from one another with respect to the attribute. Finally, the ratio scale provides the measurement information about the numbers because in addition to having all the properties of nominal, ordinal and interval scale, it also have a true zero point in it.
Students, let's start with an introduction to scales of measurement. According to N.R. Campbell, measurement in the broadest sense is defined as the assignment of numerals to objects or events according to some rules. The fact that numerals can be assigned under different rules leads to different kinds of scales and different kinds of measurement. Stevens, in his earlier writings, put forward the view that assignment of numbers or numerals under different rules or conventions leads us to different kinds of scales of measurement. Let me read a quote of Stevens. According to Stevens, scales are possible in the first place only because there exists an isomorphism between properties of the numeral series and the empirical operations that we can perform with the certain aspects of objects. This isomorphism, of course, is only partial. Not all the properties of number and not all the properties of objects can be paired off in a systematic correspondence, but some properties of objects can be related by semantic rules to some properties of the numeral series. In dealing with different aspects of objects, we can invoke empirical operations for determining equality, the basis for classifying things, for rank ordering, and for determining when differences and ratio between the aspects of objects are equal. Measurement scales are thus tools without which a scientist is almost out of business. In the process of measurement, data are represented in number form. Depending upon the type of study and data collected, those numbers carry different meanings. These meanings depend on the scale of measurement used to analyze and interpret the data. It is essential to know which scales of measurement is used in testing or research, as it will lead the researcher to the decision of kind of statistical manipulation required to analyze the data. Before formally discussing various scales of measurement, let's view Nunale's fundamentalist approach to measurement scales. Nunale proposed fundamentalist view that holds the following three assumptions about the measurement scales. The first assumption says that there are distinct types of measurement scales into which all possible measures of attributes can be classified. The second attribute says that each measure has some real characteristics that permit its proper classification. The third assumption tells that once a measure is classified, the classification specifies the type of mathematical analysis that can be employed with the measure. However, Nunale and others have acknowledged that alternatives to the fundamentalist view may also be viable for measurement scales. Nunale's view has been argued by various researchers that this is a narrow point of view that needs to be modified before it can meet the actualities of scientific inquiry. Let's first look at two major types of measurement scales, which is continuous scale and discrete scale. What is a scale? A scale is a set of numbers or other symbols whose properties model empirical properties of the objects to which the number are assigned. Various types of scales exist. One way of classifying scale is to label it on the basis of type of variable considered for the study. A scale used to measure a continuous variable is known as continuous scale, whereas a scale used to measure a discrete variable is called as a discrete scale. Let's elaborate it with the help of an example. Consider an example in which a researcher needs to distinguish his subjects into categories of gender, that is, either male or female. The categorization scale would be said to be discrete in nature because it would not be meaningful to categorize a subject as anything other than a male or a female. By contrast, a continuous scale exists when it is possible theoretically to divide any of the values of a scale. For a continuous scale, a measure of 1 or 2 is valid, and any value between 1 and 2 like 1.5, 1.25 and so on are equally valid. Any division on any unit on the scale produces a valid possible measure. Examples include things like height or weight. You could have an object that weighed 1 pound or 1.5 pounds or 1.25 pounds. It is important to note that measurement using continuous scale always involves some kind of error. For example, the weight of a person you measured to be 1.5 pounds could in reality be 1.52 pounds. Most scales used in psychological testing are continuous in nature and therefore can be expected to contain errors. Errors will arise from the mere use of a continuous scale. The number or score used to characterize the trait being measured on a continuous scale should be thought of as an approximation of the real number. Thus, for example, a score of 28 on some test of depression should not be thought as a precise measure of depression, but rather as an approximation of the real depression score had the measuring instrument been calibrated to yield such a score. In such a case, perhaps the score of 28 is an approximation of a real score of 27.8 or maybe 29.3. In contrast to numbers or score used to characterize traits in continuous scales, the number or scores used in discrete scales are presumed to be exact. Let's now study 4 types of measurement scales commonly used. A scale reminds us of a measuring instrument, a ruler, thermometer, weighing machine, and so on. Or a scale may be looked upon as a set of items, as in the Likert scale. It can also be a set of questions so constructed that entities being measured can be systematically assigned score or values on the chosen scale. Assignment of such values or scores is related to the amount of the attribute or quality and the entity process. Measurement has been categorized with respect to the amount of quantitative information the assigned number possesses. It is generally agreed that there are 4 different levels or scales of measurement. Numbers at different levels or scales of measurement convey different kinds of information. In psychometrics and in research in general, it is important to know which scale of measurement are being employed, for the kind of scale will be one factor for determining which statistical manipulations of the data would be appropriate. Let me give you a brief introduction about the 4 types of scales of measurement. The first is nominal scale, then ordinal scale, interval scale, and ratio scale. In the most basic form, nominal scale represents equality and sameness among entities. Ordinal scale determines the degree or rank to which a particular attribute is possessed by entities. Interval scale determines relative rank of the entities with respect to the degree to which a particular attribute or characteristic is possessed by them, and also how large the difference between the entities is at the zero value of the variable attributes in the absolute sense. Ratio scale, which is the highest form of measurement scale, determines all 4 relations that we discussed earlier: equality, rank order, equality of interval, and the equality of ratio among the entities or phenomena. These scales, 4 scales of measurement, are actually 4 hierarchies of measurement procedures. The lowest in the hierarchy being the nominal scale measurement, and the highest is the ratio scale measurement. That is why the expression levels of measurement has been used by some scholars for scales of measurement. It is here pertinent to record that the measurement of many physical quantities has progressed from scale to scale. Initially, men knew temperature only by sensation, when things were only a shade warmer or colder than other things. Temperature belonged to ordinal class of scale at that time. It became an interval scale with the development of thermometry, and thereafter, when thermodynamics used the expansion ratio of gases to extrapolate the absolute zero, actually the temperature became a ratio scale. The major characteristics of these scales of measurement and the empirical operations that are possible with each scale are depicted in this table. Let's elaborate this table with the properties. The 3 types of properties on the basis of which type of scale are distinguished are magnitude, equal interval, and absolute zero. In case of ordinal scale, magnitude is present but equal intervals and absolute 0 are lacking. In case of interval scale, magnitude and equal intervals are there, but there is no absolute 0 level. Last, in the case of ratio scale, all three magnitude, equal interval and absolute 0 are present. Let's elaborate more upon these scales of measurement. We will start with the most basic type, nominal scale. It consists of formulating purposeful and homogeneous set of classes or categories of entities, facts or data on the basis of some traits and assigning them some symbols or numerals as a way of differentiating two or more classes of entities or data. It may be pointed out that each category and its member are assigned the same symbols or numerals. Nominal scale is the least sophisticated and considered the lowest level of measurement. As a rule, a measurement is said to be nominal in nature if a set of entities can be assigned to have a set of classes that are mutually exhaustive, mutually exclusive, and each class is represented by a distinct symbol or label. The only arithmetical operation applicable to nominal scale is counting, a mere enumeration of members in a category or a set. The relation of equality or entity between things expressed by the sign is equal to has the logical properties of being reflective, symmetrical and transitive. Reflexivity means that every entity in a category is equal to itself. For example, C is equal to A for all values of A in a given category. In a symmetrical relationship, if A stands in a certain position with respect to B, then B stands in the same position with respect to A. That is, if A is equal to B, then B is equal to A. The third property of nominal scale, which is a transitive relation, which represents if A stands in a certain position with respect to B and B stands in a similar position with respect to C, then A also stands in that position with respect to C, which means that if A is equal to B and B is equal to C, then A will also be equal to C. The next higher scale in the list is the ordinal scale. In this scale, the entities or data are ranked with respect to the degree to which a particular attribute is possessed by them. In other words, through ordinal scale of measurement, we seek to determine the rank order or inequality of elements to which numbers are assigned. Ordinal scale has the property of higher than or a lesser than relationship symbol. In this, the three assumptions include irreflexivity, which is a logical property wherein it is not true that for any A is greater than A. It is also asymmetrical, which means that if A is greater than B, then B is greater than A. It also has the property of transitivity, which means that if A is greater than B and B is greater than C, then A is greater than C. Ordinal scales allow slightly more refined measurement than do the nominal scales, because they do allow for each entity being measured to determine whether that entity has more of the attribute in a question than any other entity of the same amount or less than. In other words, it shows a relationship of greater than or lesser than. For instance, it is easier to identify and level of willing workers in contrast to unwilling workers rather than making comparison among workers in terms of the degree to which the trait is possessed. An ordinal scale, however, does not reflect or tell how much in the absolute sense the attribute is possessed by entities or how far apart are the entities with respect to the attribute. The third level of measurement is interval scale. It is not just characterized by ordered and ranked entities with respect to some measured attribute, but the distance or difference between neighboring rank or states is also well defined and reflected. The distance between each successive interval or rank is constant in the interval scale. Interval scale represents a level of measurement in which average of a set of measurements can be obtained to give some meaningful answers. The examples of interval scale are Fahrenheit scale of physical sciences and IQ scales in psychology. For interval level data, there is no fixed 0 point, but each case has an absolute value associated with it. This can be understood by studying the measurement of a psychological attribute using interval scale. Suppose a researcher wishes to measure subjects' need for power. With an interval scale, the scores can be interpreted to mean that someone with a score of 25 is as different from someone with a score of 30 as is someone with a score of 30 compared to someone who has a score of 35. The scale provides only interval level information, but the scores cannot be compared with the reference point 0 because no such state exists in which there is a complete lack of need for power in an individual. So, we cannot claim that a score of 35 achieved by a subject on a need for power scale means half the need for power when compared to an individual who has a score point of 70. In order to make such a claim, there need to have an absolute 0 point on the scale, which is lacking in the interval scale. The highest hierarchy of measurement is the ratio scale. Ratio scale is the most valuable and sophisticated of all types as it has an absolute 0 point along with other characteristics of nominal, ordinal and interval scale. Examples of ratio scale include weight, length, time interval, speed, electrical resistance, distance, temperature in Kelvin, etc. The presence of absolute or normal 0 point in the ratio scale represents the absence of magnitude of a variable attribute. Mathematical operations in ratio scale have equal intervals between the number on its scale. Thus, if a car covered 50 kilometers in an hour in comparison to another car B which travelled 100 kilometers in an hour under similar circumstances, then according to the ratio scale, it is reasonable to conclude that car B can twice as fast as car A. After discussing, let me give you some more examples to further classify the 4 types of scales of measurement. To give examples for ordinal scale, I can quote like male versus female classification, literate versus illiterate classification. Psychological test using nominal property is Modisley personality inventory. In MPI, Modisley personality inventory, test scores are categorized in terms of introverts and extroverts. Arranging a group of students based on their marks obtained in psychology is an example of ordinal scale. To give you an example of interval scale, few are Celsius and Fahrenheit scales, calendar dates and IQ scales in psychology. Numerosity, length, weight, density, Kelvin scale, time interval and height are the examples of highest hierarchy, that is ratio scale of measurement. After discussing the 4 types of scales of measurement, the next obvious question that comes in the mind is what type of measurement scale is used in psychology. According to Kerlinger, the ordinal level of measurement is the most frequently used in psychology. Quoted in terms of Kerlinger, intelligence, aptitude and personality test scores are basically and strictly speaking ordinal. They indicate with more or less accuracy not the amount of intelligence, aptitude and personality traits of individuals, but rather the rank order position of the individuals. Kerlinger further added, most psychological and educational scales approximate interval equality fairly well. But if ordinal measurements were treated as if they were interval measurements, the test user must be constantly alert to the possibility of gross inequality of intervals. It is to be noted here, students, that most psychologists want to treat their assessment data as interval when actually it can be best described as ordinal. Why this is so? This is so because a greater level of flexibility and statistical manipulations are possible with interval scale, which is not possible with the ordinal level of measurement. Various statistical computations like mean, standard deviation, average deviation, correlation, t-test, product moment can only be employed to interval level of measurement but not with the ordinal scale. Thus, we can say that most measurements in psychology, though belong to ordinal rank, it is generally treated as interval level of measurement. Let us summarize what we have studied in this module. We studied different types of measurement scales that are used in measuring psychological attributes. The appropriate statistical procedure applied to a data set depends on the measurement scale used. We distinguished measurement scale depending on the type of variable being measured in two categories, continuous and discrete. A scale which is used to measure a continuous variable is a continuous scale, and a scale that is used to measure a discrete variable is a discrete scale. We further categorized and studied measurement scales into four categories, that is nominal, ordinal, interval and ratio. Nominal scale represents the lowest form of measurement in which numbers are used to represent categories. Ordinal scale is a set of objects or people that are ranked in ascending or descending order with reference to an attribute. Interval scale is characterized by ranked order numbered along with equivalent difference between the number. A ratio scale, the highest form of measurement, is the advancement of prior three categories in which distances between numerals are stated with respect to a rational zero rather than with respect to each other. Last, we discussed that the ordinal level of measurement is the most frequently used in psychology. A simplified, conventional and most widely accepted classification of measurement scale comprises of four types: nominal scale, ordinal scale, interval scale and ratio scale. In the process of measurement, data are represented in number form. Depending on the type of study and data collected, those numbers carry different meanings. Nominal scale is the most rudimentary type of measurement scale in which numbers are coded into categorical information. The next level of measurement is ordinal scale. In this type of measurement, a set of objects or people is ordered from most to least with respect to an attribute, but there is no indication of how far apart the objectives are with respect to the attribute. An interval scale is one in which the numbers are rank ordered, and it is known how far apart the objects are from one another with respect to the attribute. The ratio scale provides the maximum information about the numbers because in addition to having all the properties of nominal, ordinal and interval scale, it also has a true 0 point. Nunale proposed fundamentalist view that holds the following three assumptions about the measurement scales. First, there are distinct types of measurement scales into which all possible measures of attributes can be classified. Second, each measure has some real characteristics that permit its proper classification. Third, once a measure is classified, the classification specifies the type of mathematical analysis that can be employed with the measure. Measurement scales can be broadly classified into two types. A scale used to measure a continuous variable is known as continuous scale. whereas a scale used to measure a discrete variable is called as a discrete scale. Example of discrete scale could be gender, that is categorizing into male and female. An example of continuous scale could be height, weight, etc. Further, the nominal and the ordinal scales come under the discrete scale. On the other hand, interval and ratio scales come under the continuous scale. The lowest measurement level you can use from a statistical point of view is a nominal scale. A nominal scale, as the name implies, is simply placing of data into categories without any order or structure. Explaining the nominal scale in terms of its properties, it doesn't have magnitude. There are no equal intervals and no absolute 0 point. Example, categorizing gender into male and female categories. An ordinal scale is next up the list in terms of power of measurement. An ordinal scale only let you interpret gross order and not the relative positional distances. Explaining the ordinal scale in terms of its properties, it has magnitude, but there are no equal intervals and no absolute 0 point. Example, classification of height as short, medium, and tall is an example of ordinal scale. Interval scale is not just characterized by ordered and ranked entities with respect to some measured attribute, but the distance or difference between neighboring rank or states is also well defined and reflected. The distance between each successive interval or rank is constant in the interval scale. Explaining the interval scale in terms of its properties. It has magnitude, equal interval, but no absolute 0 point. Example, the standard survey rating scale is an interval scale. When you are asked to rate your satisfaction with a piece of software on a 7-point scale from dissatisfied to satisfied, you are using an interval scale. A ratio scale is the top level of measurement and is not often available in social research. It has all the properties of nominal, ordinal, and interval scale. The factor which clearly defines a ratio scale is that it has a true 0 point. Example, temperature in Kelvin scale is an example of ratio scale measurement. Let us now summarize what we have learned in this module. Different types of measurement scales are used to measure psychological attributes. The appropriate statistical procedure applied to a data set depends on the measurement scale used. Measurement scales are classified depending on the type of variable being measured. Measurement scales are categorized into 4 categories: nominal scale, ordinal scale, interval scale, and ratio scale. Nominal scale represents the lowest form of measurement in which numbers are used to represent categories. In an ordinal scale, a set of objects or people is ranked in ascending or descending order with reference to an attribute. Interval scale is characterized by ranked, ordered numbers along with equivalent difference between the numbers. A ratio scale is advancement of prior 3 categories in which distances between numerals are stated with respect to a rational 0 rather than with respect to each other. The ordinal level of measurement is most frequently used in psychology.